Today we're going to be talking about more laws involving indices. And yesterday we talked about how addition and subtraction relate to multiplication and division of exponents and indices. Today what we're going to be doing is talking about negative values and zero values. So first thing we're going to do is take a look at the first rule. I have a times b in parentheses, and then I have that raised to the power of n. So that might look like something where you have 4 times 5 squared. What that means is that I have 4 times 5 times 4 times 5. So that's going to get me 4 squared times 5 squared. What we can see is that if you have a value in parentheses raised to another value, then that index raises both bases. So I now have a to the n times b to the n. So for example, if I had pq to the fourth, that means I have pq times pq times pq times pq, or p to the fourth, q to the fourth. Now you want to be careful when you're multiplying these out that you don't put in a multiplication symbol. That's a bad idea. Because what happens is then it looks like you have p to the fourth x q to the fourth. And that's really not something that we're looking for. Let's take a look at the next example. I have a fraction raised to a power. So for example, let's say I had something like 2/3 squared. That means I have 2/3 times 2/3, or 2 squared over 3 squared, which I can then expand and simplify to 4/9. So my next example over here, then if we go back to the original and we see whenever you have a fraction raised to an index, that index is distributed among both bases. So for example, if we take a look at 7 over k to the third, that means 7 over k times 7 over k times 7 over k, or 7 to the third over k to the third. So again, we have 2 more laws of indices. Alright, what we're going to do now is take a look at the negative indices. What does that mean really? Well, if I use the law of indices, and I start out with something like 2 to the 5th divided by 2 to the 5th, then if we think back to our law, that means I have to take 2 to the 5 minus 5. That's going to get me 2 to the 0. 2 to the 0. What does that really represent? Well, let's take a look through direct calculation. I'm going to expand all my 2's. So I have 2 times 2 times 2 times 2 times 2. Divided by 2 times 2 times 2 times 2 times 2. And I start canceling values out. And I see that I'm left with exactly the same number of values in the numerator and the denominator. Anything divided by itself is 1. So 2 to the power of 0 equals 1. What does this have to do with negative values? We're going to get there. So if I move ahead and take a look at an example here where I have 7 to the third divided by 7 to the 5th, if I use the law of indices, then I have 7 to the 3 minus 5, which means I have 7 to the negative 2nd. Here's the funny thing about exponents. We don't like to have negative exponential values. So what I'm going to do is go back again to direct calculation, and take a look at 7 to the third over 7 to the fifth, which means I have 7 times 7 times 7 over 7 times 7 times 7 times 7 times 7. So if we look here and then we start crossing out similar values, I have 3 7s here, 3 7s here. I'm left with 2 7s in my denominator. Doesn't mean that there's anything left. I have 1 as my placeholder over here, and I see that I end up with 1 over 7 to the second. So what we can say, therefore, 7 to the negative second power is going to be the same as 1 over 7 to the second. Super, super important. You have to have positive exponential values, positive indices. So how would you rewrite a to the fourth divided by a to the seventh? If you said a to the negative third, you're almost right. Because if you remember, we have to have a positive value. So the way to make that positive is to change it so that it's in a fraction, and you now have your negative index now becomes positive when it's placed in a denominator. Super awesome stuff. So something to remember, whenever you have, so first we need to remember a to the 0 equals 1. Anything to the power of 0 equals 1. When a does not equal 0. What happens if a does equal 0? 0 to the power of 0? I don't know that it makes sense that it should equal 1. 0 to the power of 0 equals 1? I don't think so. That seems a little unusual, a little weird, and a little scary. So let's go back to the next part. Final answers must always contain positive indices. Does always mean like sometimes kind of? No, always, always, always. So if we take a look at the next rule, we have a to the negative n equals 1 over a to the n. So again, just to refresh your memories here, whenever you have a negative exponent, you can make it positive by putting it in a fraction or changing it. If we think about it for a moment, let's take a look at this example. 5 to the fourth to the negative second. I can't have negative exponents. What am I going to do? Well, let's make it positive, but it's a fraction. That's all right. We can still make it positive by taking 1 over 5 to the fourth to the second, which means we have 1 over 25/16. All right, 1 divided by 25/16 is going to be 16/25. That might seem a little confusing, but how about we look at it in a different way? Remember the rule where if you have a over b to the n means you have a to the n over b to the n? Yes, you remember? No? All right, go back and remember. Let's apply that to this problem. So I have 5/4 to the negative second. That means I have 5 to the negative second over 4 to the negative second. All right, Now, I can't have, if you remember, final answers must always contain positive indices. How do I make this index positive? Well, I take the whole value, move it to the denominator. But now I have this value 4 to the negative second. Any guesses as to what I can do to make this value positive? If you guessed that I can put it in the numerator, go ahead, grab yourself a smoothie, a soda, or some sort of pastry. You deserve it. So that means now I have 4 to the second over 5 to the second, or 16 over 25. Same answer, two different ways of going about that value. And back for something else to think about. If anything to the power of 0 equals 1, why doesn't 0 to the power of 0 equal 1? Back to that original problem that I had you guys think about. The answer will blow you away. So that's pretty much it. Here are some problems. If you feel like you have a little extra time and you want to work on some problems, you can go ahead and do these. We are going to talk about them later in class if you like. That's pretty much it for today.